So my topic, after the coffee break, I hope you are all awake, is to introduce what is our way, how is Primetals concretely supporting the clients on this way to transforming to green steel. We called it digitalization as the catalyst for green steel. So this morning, Dr. Fleischhandel showed this slide about the three phases, meaning optimization of the existing plant, then the transformation, and finally to arrive on green steel and how. So and we will give some examples how we transform the individual phases. So starting with the optimization phase, I think also Mr. Steinparzer has shown that. So all the steel plants, which are of course not identical, yeah, every steel plant has its special challenges, opportunities, frameworks. So there is a existing process, and the first step is of course to optimize what's there, also to minimize of course capex investment in the beginning and to lower the OPEX from the very beginning. So we have different levers. Of course, energy management, yeah, to cap here the maximum in case the energy prices are low, to increase the use of electricity, for example, in case the price is low. Maximize the efficiency of the existing plant. And of course, intelligent monitoring of the process equipment and the quality of the product in order to maximize the yield. Yeah, we will also save, of course, emissions if we increase the yield or if we avoid the production of steel which is later downgraded or maybe even remelted or scrapped. And yeah, the levers are showing from the left side. Of course, we have some tools also in the automation system. I think Mr. Melcher also has shown that. Yeah, how to maximize the use of CO2-friendly raw materials in the primary phase. How to minimize the energy demand. Of course, also by sophisticated level 2 system, yeah, that control the plants in the most economic way. And yeah, good, this is in the end also a question of price and how CO2 neutral do we want to be. So what is the maximum economic use of green energy? Yeah? Because also this price is fluctuating. So in the end, the aim is to the right. We want to maximize quality and yield by, of course, being as energy efficient and as CO2 friendly as possible. Then, yeah, there will be a what we call transition phase, meaning new plants will be existing besides existing ones. So we have heard, I think, several times that the blast furnace route will be abandoned. So there will be new production units. Might it be smelters? Might it be EAFs? Might it be whatever? So for a certain point of time, old and new production units will be operating side by side. So several challenges are arising from that. I think also Dr. Linzer has explained that, so we call it transformation of production. So the first priority is, of course, how to produce the legacy product that you as a steel supplier, in case you are producing on the new route. And then from an OPEX point of optimization, of course, this is the middle one, how to optimize the use of the old units and the new units side by side, and how to empower the people who operate the plant to do so properly. And then, of course, looking also in the future, how to develop new products, how to react on new requirements which are coming from the market. And for each of these phases, I will have some examples now. So how can we support all this by digitalization? It's the main question. And let's starting from the left, transformation of the production. And we will show you now maybe a little bit a surprising picture. What you see, of course, is an airplane cockpit. And airplane pilots are regularly retrained in simulators. And the idea is to do a very similar thing, meaning retrain the operating people, retrain the maintenance people for the plant before the plant is even there. So meaning, okay, we call this virtual plants. So on the right, you see, what we call the real plant. This might be an EAF, this might be a DRI plant, consisting of the plant level itself, automation level 1 and level 2, and the operator interface. And the idea is, before the plant is being there, giving the client an opportunity to train the people in a dry run, what we call virtual plant, or you can also call it digital twin. So we will cater infrastructure to replicate the plant in a test environment which is safe. And then the idea is, again, similar to the airplane industry, to train the people with a trainer in the background that can modify some KPIs in the production route. We can simulate some faults in order to give the people the possibility to train on the real plant before it is even there. So this is also something that we discussed, for example, with Saarstahl. So there are concrete discussions with concrete users. This is in a very preliminary stage, but concrete order, then sorry. So again, sorry, it is included, because I know the discussion from Saarstahl. Sorry for mixing it up. So they do not know in the moment to operate an EAF. They have, of course, experts from the outside, but the operating staff is not trained. And this infrastructure for sure will become in other plants also. So what benefit is coming from that? First of all, the startup is accelerated because the people are more experienced. They know already how to operate the plant, how to react on maybe process anomalies. We can also minimize shutdown duration in case a fault is coming up. And all this will also, as you see to the right, lead to minimized unplanned shutdowns. I think unplanned shutdowns is the biggest nightmare of all the plants, because you have downstream production routes, you have incoming raw material, so everybody wants to avoid that. Hybrid operation. How do we help the customer to optimize the OpEx if both, meaning the blast furnace routes and the whatever new route is running side by side? We help by challenging these challenges, by mitigating these challenges. So raw material supply, This is also what we learned this morning when we heard about scrap availability, scrap preparation. So we can help with level 2 models, with AI in sorting algorithms to provide the optimal raw material in order to produce the material on the new routes as effective as possible. Whenever green energy is available, either as green electricity itself or maybe green hydrogen, we can of course reschedule the planning or use more of certain raw material in other phases. And then of course by an overall planning and scheduling system, we can optimize the raw material flows, secure the availability of the raw material when the new grades are being produced. I think this was also coming early this afternoon. So scrap availability is one point, but also the timing for the proper quality is a point. And last but not least, we can optimize alternative production routes through the different agents and through the different plants. One topic that will later be presented in detail by Mr. Margin, coming also from electrics and automation, is what we call active power feeder. This is in a nutshell, a big electrical converter that will operate the electric arc furnace in a very grid-friendly and EAF-friendly way. I think I will skip that in the interest of time. We will also give you some insights about first references that we are already executing. So this is not just PowerPoint theory. And we think this is one mega trend in the industry that will come because the grids are getting weaker, more photovoltaics or whatever are coming up. The grid codes are getting more stringent. So it will be most likely in 5 or 10 years from now that every electric arc furnace needs to have something like this. So regarding product development, so how can we help in developing rules of producing the existing products which are established on the blast furnace route on new routes. So Mr. Linzer also gave some insights. So which kind of tools do we have? Or what is the optimization routes that we are looking for? I think first of all, the most important thing is avoiding mistake and avoiding losses. And if we produce less downgraded material, then we have also less CO2 emissions, yeah, because we increase the yield. If we have new production processes, we need to introduce this also in our level 2 systems, so we have overall optimization of the processes. And then we can, of course, help also the customers, metallurgists and technologists in supporting them with tools, algorithms, AI-based models in order to be faster in the development of new products. So here, again, this is an overview. We have a system which is called through process quality control, TPQC. We have a double-digit number of references globally. How many, Kurt? 20, 30? 35? So what is this tool doing? So we have an integrated approach of processing the primary data from all the individual production steps. And we are comparing the actual data to the thresholds that are defined by the metallurgical people and the technology people, and then we can control the production in a quite sophisticated way, reacting on process anomalies, changing some process parameters in order to increase the yield. So that's the main topic. Of course, we can also simulate with the metallurgists which kind of boundaries can we change in other conditions to produce different products on the lines. And the evaluation that the tools is giving is, of course, also giving instructions to people who are new to the operation, to the plant, or in case the customer wants to do some trials. And last but not least, as we have most of the data of the individual coil or slab or whatever kind of finished product you are looking for, we can also create a kind of digital passport of this end product. This is not meaning for CO2. This is not covered in this module. This is meaning product properties, product quality, and product history in the end. So, in a summary, okay, these are the tasks and how we solve them. People, I think this is the most important thing. Yeah, we need to support the people with the proper tools, with the proper information in time to enable them to fulfill their task. This is meaning professional people who are now changing from a traditional production route to an alternative one, as well as newcomers, because we see that also in many of our industrial partners not even have they the challenge of energy prices being high, requirements changing now. Also, people are getting much more difficult to get. Mr. Fleischhandel also explained this morning that we are chosen as a technological partner for a mill in Norway, which will be greenfield. So in this area, it will be, of course, not so easy to find experienced people that know metallurgical know-how. So we need to support these kind of clients with the proper artificial intelligence and tools. And last but not least, we need to empower the plant operators for continuous improvement and development, because once these production routes are changed, then the next challenge is starting. This blast furnace route, as I heard it 10 years ago in Dillingen with the opening speech, this route has been optimized for over 400 years. And we are now switching to EAFs or smelters, and this is only the beginning of the next optimization cycle. And there we are sure that our solutions are giving the plant operators and the steel producers the proper tools and support. And with this, because I'm carefully to meeting the time limit, I want to close, and I'm, of course, happy to answer some questions if there are. Thank you very much.
Thank you very much, Mr. Zeiher, for sharing so many specific digitalization solutions, assisting sea producers to just master the green transition. We have received some questions. Maybe you choose one of them to answer, please.
Okay, maybe I check the second one. Which kind of data sources do we need? So in the beginning, when we developed the systems first, we had our own data lake, which needed to be engineered specifically for the projects, and this has proven to be maybe not the best way. So in most of the plants, I will not say the name of the company, but there is in steel industry one way of getting actual data from the lines, and this is stored on specific servers which are delivered by an OEM company, and we are connecting directly to these existing databases. So we do not need special data engineering, we have this connectivity. We also created an infrastructure which we call architecture of the future. So meaning this is a data architecture covering data from level 0 up to level 3 with a universal connectivity. So we can build special plugins in order to connect to the databases. We do not need to reconvert all the data. So this is the task. We are also quite flexible in this regard.
Okay.
I hope this answered the question.
Perfect. Okay, thanks again, Mr. Zeiher.
Thank you very much.